All right, guys, let's take a look at some translations. Translation is under our unit referred to as rigid transformations. So by rigid, it means we're going to transform an object, but without changing its size or shape. We're going to maintain or preserve congruence. All right, so these rigid transformations are going to preserve congruence. All right. A translation is a really big word. A lot of people think translation, well, we're just sliding something. That would be a simplistic layman's term for a translation. All right. Well, if we're talking about sliding something, we're going to be taking some object. We're going to be sliding it in some direction, and without changing its size or shape, it's going to end up in a new location. All right. Point A here is going to end up here, but it's no longer point A. It's now the image of A. So the way we do that is we put the letter with a little apostrophe above it. If this is point B, this would be the image of B or B prime. Point C, again, here's where C ended up, the image of C or C prime. Now, if we want to be a little bit more, give it a little bit more explanation, a little bit more of a textbook definition for translations instead of just slide, what's really happening is we're going to have every point move the same distance in the same direction. Now, the problem with a translation is we don't do a very good job of explaining a diagonal move. If we were just moving horizontally, we're just moving vertically, we're pretty good at explaining those directions. Diagonal, as humans, we don't do a very good job. So instead of trying to explain diagonal movement, we're going to break, even though A went from here to there, we're going to break its movement into what's called a horizontal and vertical component. And we're going to come down. Now, please understand the point did not go way over here to the right and then come down. All right, that is, we're breaking the movement into two different components. The actual movement was this diagonal movement. Okay, and so we want to be able to explain. All right, so a lot of times when we are explaining, we're going to use what's called a coordinate notation. And what that would look like is we'll take the symbolism of a coordinate point, which actually represents every point on our object. We're going to use an arrow to symbolize movement. Every point is moving. And then we can talk about horizontal and vertical movement. Since X is horizontal movement, we can tell how much we want to add or subtract to create horizontal movement. The Y values are up and down movement. We can take the Y value, and I'm going to use letter K. Why? I have no idea. But when we discuss in mathematics, horizontal and vertical movements, we use H and K. This can also be done with what's called a translation notation, which is only slightly different. With translation notation, we would just use a capital T, which signifies translation, and then we would just, in parentheses, we would write our horizontal and vertical component of movement there. All right, so an example would be every point moves. Let's say I said x minus 3 and y plus 2. So try and understand this mathematical sentence equates to a full English sentence. This first part, again, means every point. The arrow means we're moving. And if we're subtracting 3 from the x value, that's going to be to the left, since we're subtracting 3 units. And since we're adding, that would be up 2 units. I could do that with a translation notation just the same by putting in a -3 and a +2 there. All right? And try and also realize that, let's look here. So if I gave you here's another example. So I gave you a translation notation of 3, -4. However many points that is, every point, whatever it is, let's use the point R. Every point is going to be going to the right 1, 2, 3 units, and it's going to be going down 4 units. All right, and here's where the image of R would end up. Again, R did not go over to the right and down. R traveled in this diagonal movement. So the question is, well, how far did R really travel? It did not go 3 and then 4. It did not travel 7 units. But if we look at this as a right triangle, if that measurement is 3 and this is 4, we can use the Pythagorean theorem to find out how far this diagonal movement is. So 3 squared plus 4 squared equals c squared. And I don't need to put in a negative because we're not looking at this as a downward movement. We're just looking at it as a triangle where these lengths would both be positive. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. And I can't forget to square root both sides, and it turns out that the movement was actually 5 units long. All right, so realize coordinate notation, again, is written in this way. Translation notation, it's movement that's got to happen to every single point. The resulting translation is not only going to preserve the exact same shape, which is called congruence, but since the shape was not flipped, you also preserve what is called orientation. You preserve orientation anytime you transform an object and you do not end up flipping the object. If you flip the object, then orientation is not preserved. Translations, hope you guys do a good job. Good luck.